So, firewalls. People ask about firewalls. Here's the basic information about them. The earliest firewalls were packet filters. They would just look at the header information like the port number and the IP address and filter traffic on that. And so this stops really obvious attacks, but it's a very simple technique. Stateful firewalls have a state table. So this is what you have in, say, the Windows firewall. If you turn on the Windows firewall, then what happens is it knows if there's an established connection, it will let it through. So if you send a request to a server, then it will let the replies from that server through. But if some server sends you data and you didn't ask for it, it will be blocked. So it knows that this is a connection established by you. So you can go out and ask for anything, but anything unexpected coming in is blocked. That's a stateful firewall. So the same thing will be approved if you've asked for it and denied if you haven't asked for it. Is it true stateful is useless for IPv6? No, I don't think so. I think exactly the same logic should work on IPv6. The thing people don't like is network address translation in IPv6. Although you can do it, and it works just the same, the Internet Engineering Task Force disapproves of it because technically you don't need it. And then there's proxy firewalls. We talked about these before. So instead of having a direct connection to the internet, you connect only to the proxy, and then the proxy will go fetch pages for you, and you're just seeing whatever it approves. So if they want to block something, like the Great Firewall of China, where they don't want you going to Google, you can't get there because you cannot send any direct traffic to anybody. You can only talk to a proxy, and the proxy will refuse to fetch pages you're not allowed to get to. Then there's application layer proxies that can use application layer data like URLs, and often specialized to a particular protocol. These are the smarter protocols. And circuit level proxies operate at session layer. And what they do is they can forward many protocols. So SOCKS, this is what Tor uses. It's a SOCKS proxy, so it can take all your data in any protocol and forward it to servers. All right. And then now an old technique people used to use, and now it has come back on Azure, is a bastion host, where you have a special computer just to receive internet traffic and filter it. And it's supposed to be stronger than most, hardened, and provide a specific service. So, and you can do this on Azure. They offer you using a bastion host for RDP traffic, because if you have a direct RDP port open on the internet, then it gets a lot of brute force attacks. And Azure finds that to be a security flaw, so they recommend using a bastion host to protect your RDP. All right, a dual homed host is a host that sits between two networks and has two IP addresses, and you have to first log into the host and then log in here. This is an old technique. These days you would use a VPN concentrator to do this. And there's a screened host architecture where the router would only let traffic go to the bastion host, and you have to authenticate here to get inside. And again, this is the sort of thing you would now do with a VPN or with a, people are talking about it before, IEEE 8021X with a radius server is another way to do the same thing. And someone asked about the China firewall. Let's go back here. The Great Firewall of China is like this. So the Great Firewall of China, you cannot connect to the internet. If you try to send traffic to Google, you send a SYN to Google's IP address, the firewall will intercept it, and it intercepts all requests. It does not forward them on. It reads the request, and then it will only make the request on your behalf if it is approved. Same thing's true at most companies. They want to block things like known malicious sites. So they have a constantly updated table of bad IP addresses that you don't want anyone going to, and when anyone tries to send traffic to that IP address, it blocks it. So that's why inside here, your network device will not pass any request that you make through unless it is approved. All right. And then there's DMZ. This is commonly used. So you have the internet, you have an external firewall that does some filtering, and you put your public servers here, like web, email, and FTP, and then you have your private servers here that have the confidential data for your company, and you have a second layer of screening that's more strict. So usually you make sure only real company employees can get in here, and anybody on the public can get in here. and they call that a DMZ, a military term, a semi-trusted network. So does the proxy have to install a trusted certificate to the end device? Oh yes, that's a very good question. If you do this, and you man in the middle HTTPS traffic, then errors are going to pop up in the browser here saying somebody's man in the middle in your traffic. And so to avoid that, you either have to purchase a real ISP trusted certificate, which they are not supposed to sell, but they do, or you have to install a special trusted certificate in the operating system or the browser of your end devices, and that's what some companies do. But that's a very good question. If you intercept HTTPS connections, then there is a security issue, but most companies do it now because they're not willing to let any traffic enter or leave the network without being able to inspect it for malware. You can also have a DMZ with one firewall where you have internet traffic and it just has one set of rules that's more permissive to go here and another set of rules that is stricter to go here. Yeah. And okay, so a modem is a device that takes the digital traffic and turns it into analog signals that can be carried on a phone network or on a cable network. And DTE, DCE, this is data terminal equipment and data circuit terminating equipment. These are the serial cables used to connect to your internet service provider if you get something like a T1 line. There's a place called the DMARC, which is the point where these two things meet, and that is where the ISP's responsibility ends. The internet service provider provides service only to the DMARC, which is a box on the outside of your house or a network closet somewhere. They provide internet service to there, and it is your responsibility to add cables and stuff to distribute it from that point on. The CSU DSU is a clock signal. The serial connections used here are synchronous, so you have to have a clock signal to synchronize them, and there's a special device to create that here. If you take the Cisco classes, you spend quite a lot of your time correctly configuring these things so they work. You get used to doing it. So secure communications. You can have authentication protocols, VPNs, and remote access. So the authentication protocols, these are ways to make sure you know who people are. So PAP was the original one where you just send a password in plain text over the wire with no encryption. This is, of course, terrible. Anybody can sniff it if they can get in the middle, and they can just replay the packets. So this is really bad and shouldn't be used. A CHAP was the first attempt to improve it. So the server sends you a challenge. The user adds the challenge to the password and hashes it and sends the hash over the network. So now you can prove that you know the password, but the thing you send over the network is not simply equal to the password. And this turned out to be pretty good, but the problem is it does require that you have the plain text passwords of the storage of the password on servers, because the server can't store the hash because it has to keep sending different challenges. So it's not considered a modern technique, but it's a lot better than PAP. 8021X is the one I mentioned. This is port-based network access control. So you have, when you connect, you are a supplicant, that's the client, and then you go to an authentication server that authenticates you by recognizing your password or whatever authentication method you're using, and after it decides that you have authenticated, then it will give you access to the network. So you connect with EAPOL EAP over LAN. You connect here to the authenticator. That goes to the Radius server, which has something like password hashes storage, so it can recognize if you have the right password. And if you pass that test, then it lets you into the internal network. All right, so there are various versions of it. An old version, EAP MD5, was considered pretty weak. LEAP was a Cisco attempt to improve WEP, and it turned out also to be cryptographically weak and should not be used anymore. EAP Fast was a Cisco protocol designed to replace LEAP, and that seems fine. It uses a protected access credential. And EAP TLS uses the public key infrastructure, like HTTPS, and it's very secure. It used to be considered costly because certificates used to be very expensive. Now, for the last several years, there's been a free certificate authority run by the EFF, and so certificates no longer cost any money. So this might come back into vogue, having certificates at both ends. Most of us are not doing that yet. TTLS is another one, tunneled transport layer. This allows a client to use a password instead of a certificate, so it's easier to deploy, but not as secure as having a certificate on both the client and the server, which is probably the most secure method, but I don't know anybody that's doing that. In principle, you can, but I I've never used any device that actually does that. And there's PEEP, is protected EAP, which is similar. All right. So let's try another Kahoot. Yeah, people should go to RSA. There's going to be a student day, I think. It's usually Thursday when you can get it for free. It's worth extra credit. I recommend going if you haven't been. I'll be there in the Dark Arts Village. Well, I guess I'll start it. Seems like a few people have fallen asleep. Such is life. All right, so what firewall uses only header information to decide whether to allow or deny traffic? Yep, that's the packet filter, the first generation firewalls. Very simple, but not very effective. Which one runs at OSI layer 5? That's SOX proxies. All right, which one gives you port-based network access control? (8021X) that has many different protocols inside there, but one of them is in fact MAC address filtering. They call it port-based network access control. All right, which one of these is vulnerable and should be avoided? Leap. Leap is the Cisco one that has been hacked and should not be trusted anymore. All right. So there's Damien. All right. Well, let's do one more. I think we finish off this chapter. All right, so VPNs. We talked about these. So there's quite a few different types. The goal is to create a virtual private network, so it is as if you had your own wire going from your machine to the server and nobody else could share the wire. You used to do this actually by making a phone call and going over copper wires. It was true that you had one wire just for you to use. That was the first, essentially, VPN. But now that phone calls and internet are using many shared lines, so many channels of traffic are going over the same wire, then you got a problem. People can see it. So you're trying to create a technique to virtually simulate this with encryption so that your traffic, even though other people can see it, they can't read it or modify it. So it is as if you had your own dedicated line. SLIP was a really old one from the 80s. And This was a layer 2 protocol. This would just carry traffic, but it did not add any encryption. Point-to-point protocol added some encryption to it. So this was another one using HDLC. PPTP was a very popular one. VPN protocol built into Windows. I think it's still built into Windows. It's built into Linux distributions frequently. It's been around forever. It's old and not considered very safe. There are ways to hack into it, but it was a VPN protocol. L2TP is a tunneling protocol. It does not provide any encryption, but it does encapsulate packets and deliver them. So it is a delivery tunneling mechanism, but it's not encryption, so it's typically combined with IPsec. IPsec is the encryption designed for IP version 6, and if you combine L2TP and IPsec, you get a very popular, modern, secure VPN. Now, IPsec is very complicated. It has encapsulating security payload and authentication header, and these run on these strange protocol numbers, neither TCP nor UDP. So it will not pass through most home routers, which is annoying. So there's various modes of it: host to gateway, gateway to gateway, and host to host. And there's tunnel and transport mode. In transport mode, you have protected data, but you keep the original IP header. In tunnel mode, you take the IP header and also pack that in a new packet. Hard to really understand why you would want these two different modes. In practice, you probably just want to use tunnel mode all the time. Anyway, all right, there's SSL, is the original encryption technique for HTTP traffic. It's now deprecated. All versions of it are old and insecure. Now we should be using TLS. This is the more modern. And if you have a VPN that relies on TLS, it's much easier to use, of course, than IPsec for the end user, because you've already got things like a browser that can connect to HTTPS. IP version 4 versus IP version 6. IP version 4 used 32-bit addresses, and there are not enough of them. There's only a total of 4 billion of them, and there's more devices than that on the internet. So because we were running out of addresses, we moved to IP version 6 that has 128-bit addresses, so there's a lot more of them. That's the main difference. All right, and so remote access is another issue where you want to remotely administer a server. But here we're just going to talk about internet connections for a minute. ISDN was the first digital network, so you did not have to move your internet traffic over a voice phone line. You had the basic rate interface and primary rate interface that gave you different internet speeds. DSL is what a lot of us are using now. This uses very sophisticated encoding to squeeze a lot of bandwidth over an ordinary phone line by encoding data in very subtle changes in the phase, amplitude, and frequency of the traffic. You can get many megabits per second through a normal phone line, and it depends on how far you are from the central office. If you're close to the central office, you can get up to 20 or 50 megabits per second. But it only works in cities where you're near central phone offices. All right. Then there's cable modems through broadband cable. So if you can get cable to carry cable TV, you can also move your internet traffic through that. Again, only available where cable TV goes. So if you're out in the country, both of these will not be available to you. Now, one technique to authenticate you is where the user calls to say, I want to connect to the network, and then you hang up and the system will call you back at your known home number. This, of course, won't work when you're on the road, but it will work at your known home, and that way it helps protect non-employees from getting on, prevent that. It only calls you at a pre-configured number. An easier technique would be to use caller ID, where it reads the caller ID in your phone call to see if you're the known person. The problem is caller ID is not authenticated. It's like the from email address. It can easily be spoofed. So this is a relatively weak security measure. Remote desktop is when you want to control a server remotely. Unix used to use rlogin and RSH. These are old remote access systems that were clear text and poorly authenticated. There's modern techniques. VNC and RDP are the modern techniques. VNC is typically used on Unix servers to give you a graphical desktop, and Remote Desktop Protocol is Microsoft's licensed version of Citrix that gives you graphical control of Windows Server. There's also ones like GoToMyPC and LogMeIn. These are companies that connect from a server and let you install an agent on the server and an agent on the client, and then you can remote control a machine graphically. There was a similar product that recently got hacked. In fact, a week or so ago, some remote control product got hacked. Anyways, then you got desktop and application virtualization. So virtual desktop infrastructure is what I'm using actually in my consulting gigs. They give me a virtual machine on Azure, and I have to log in with a VMware Horizon client. And I can only use that machine to connect to the network. I can't use my machine directly. That way I can't install any malware. I can't leak any secrets out. This is what a lot of people really want to do, especially since the pandemic, is just make people connect to a virtual infrastructure under the control of the company. You can also have just an application virtualized where everybody is just using this application on a central server. Screen scraping is a way to, you can have software that reads the graphic display and puts it in packets and sends it back to you. That's how VNC works. RDP does not work that way. All right, and then of course, instant messaging for people to talk to each other. In the old days, there was IRC, Internet Relay Chat, was a text-only communication used on Unix for people using Unix servers. Big in the 80s and 90s. Some people still use it. Hacker groups often talk over IRC. It's sort of a point of pride to learn how to use IRC if you want to get into the hacking underground. There's an incredible amount of spam and porn and malware on IRC also. AOL Instant Messenger and ICQ were ones people used a lot to find friends and chat. They're still around, I think. They use this XMPP protocol. A lot of them do. That's the open source protocol used by these things. These things tended to be insecure. People tended to share files over them, and they tended to be poorly written and have things like buffer overflow vulnerabilities and such. So a lot of people would get hacked through these things. I don't know how common they are to be used anymore. Skype is still around, though. Microsoft bought it. Then there's remote meetings, GoToMeetings, Zoom, and we're using Twitch. All these do the same thing. Enterprise companies will none of my clients will let you use Zoom. Zoom is not considered secure enough for enterprises. They make you use Cisco WebEx is what they like to use, which is very annoying. It doesn't work very well, but it seems to meet their desirable security goals. Anyway, Citrix has one, Microsoft has one. You can send audio and video and share your desktop and all that jazz. There used to be these personal digital assistants before smartphones where you would keep track of addresses and such in them. Nowadays, it's mobile devices is the modern term, which is basically all iPhone and Android phones these days. And so there's a lot of security issues. One of the main problems with a phone is you are likely to lose it or have it stolen, so then the data on the phone would be at risk. So you got to make sure it's encrypted and there's a PIN code. And if it's for company data, they typically put an agent on it so they can remotely wipe it. And also they can use that agent to prevent you from installing unapproved apps and so on. And it would be good to use secure wireless connections and consider whether you want to allow them to use Bluetooth on there. Wireless Application Protocol is a way to provide web services to handheld devices. I don't know how much this is used anymore, but it has a markup language and a transport layer security to provide secure web services to handheld devices. As far as I can tell, all modern smartphones just use normal web services and APIs. I don't think they use this anymore. I don't think I've ever used it. It has a special browser for this purpose. Yeah, that's what I thought down here. It's disappeared since 10 years ago. So there were these things, WAP gateways and such. And then there's content delivery networks like Cloudflare that I'm using. If you have a website and you have a lot of people using it, then your server can't handle the load for two reasons. In the first place, it can only handle so many packets per second. In the second place, your server is only in one location. And if you have customers in another country, they'll get slow response going that long distance. So you use one of these content delivery networks like Akamai is the big one that has servers all over the place, and they will fetch your content and make a local copy and serve it to local customers so you don't have to have the capacity to handle the bandwidth, and it's near all your customers. So this is quite common. Everybody uses these. I use it all the time. It's very nice. It protects your server and provides better service to the customers. All right. Oh, all right. I'll pause this and do the Kahoot after 10 minutes. Rouhani has asked for a 10-minute break before the Kahoot, so that's fine. Sure. Okay. Let me just stop this recording.